This table right here is to recap what the part 1 video was talking about. So if I give you a quadratic equation, and this is still the general form that we've been using, the a value tells us whether or not our parabola is going to open up or down. So if it opens up, we're going to have a minimum, and if it opens down, we're going to have a maximum. So when A was positive, that's when it opened up. When A was negative, that's when it opened down. The vertex, which is the max or the min, was identified using the h and k values, and we must write it as h comma k. Stretches and compressions, if the a value was something other than 1, that's when we would have those. So if a was greater than 1, it would be a stretch. If it was between 0 and 1, that's when it's a compression. And this part right here is just talking about the pattern. So if I gave you the graph and not the equation, we can look at how it's moving from one point to another. More specifically, from the vertex to the next point, that's 1 unit to the right or to the left. And that can tell us what A would be. The axis of symmetry, that's the line that we usually use a dashed line for. Okay, it's the line cutting our parabola in half, and it will be located at the line x equals h. Let's take a look at this first example here. Using the equation, we're going to identify some key information and try to graph it. When I look at this equation, the first thing that I notice is that A is -4, H would be 2, and K would be 3. Using those bits of information, I'm going to determine what characteristics or what key information that I have about the graph. So the first thing I want to talk about is a compression or stretch. When I look at this, A is 4, so that means I have a stretch because A is greater than 1. The negative tells me that it's going to open down, or I'm going to have a maximum. That maximum is called a vertex, and the vertex is always written in the form h comma k, or in this case, 2 comma 3. Plotting my point 2, 3 would be right here. I know it's going to open down, but I need to plot some more points if I'm going to be able to draw the graph. For any parabola, you should plot at least 3 points. So I already have one here. To plot my second point, I'm going to use the A value. So I'm going to move right 1 down, because I'm opening down 4 units. Okay, I moved right 1 down 4. And again, that's because of my A value. That's how I knew how to move. My axis of symmetry is located at x equals 2. It will always pass through the vertex. Okay, I'm going to repeat that one more time because it's important. The axis of symmetry will always pass through the vertex. That's why it's passing through the x value. And using the axis of symmetry, I can get my third point. So instead of being right 1 unit, I'm going to move left 1 unit, giving my third point at 1, -1. So this is what the parabola would look like. And it makes sense because it's a more narrow graph than what we normally see, and stretches would be more narrow, whereas compressions would be wider. Next. Okay. The first thing I want to do is identify A, H, and K. A here is 1/2 because that's the number in front. H is normally inside of the parentheses with the power. However, I don't have anything inside of the parentheses. So h would actually be 0. And k is the number on the outside. So here I have a 5 on the outside. Going in order, the a being 1/2 tells me two things. The first thing it tells me is that it is going to be a compression. I say that because 1/2 is between 0 and 1, meaning our graph is going to look wider. It also tells me that it's opening up because the a was a positive number, and if it opens up, I'm going to have a minimum. That minimum is our vertex, and the vertex is always in the form h comma k, so it's at 0, 5. I'm going to plot my vertex first. 0, 1, 2, 3, 4, 5 is right here. I know it's supposed to open up, but again, instead of just drawing a random parabola, I need to plot at least 3 points, giving me the shape of the graph. I'm plotting my second point using the a value to help me. So we always move right or left 1. So I'm going to move right 1 up however many the a value is. So I'm going to go right 1 up 1/2. And also left 1 up 1/2. And the reason why I could do the left up 1/2 is because of that axis of symmetry, which in this case is located at x equals 0, or the y-axis. Okay. Moving on. For these four, we are given the graphs, and I want you to write the function. And we're also going to include the domain and the range. So you should have the function, the domain, and the range in your final answer. Okay? Looking at the graph, I see that my vertex is at 2, -5, meaning I know my h and k values. In the function, we have h and k, but we also have an a value out front. Well, looking at this function here, I know that my a value is going to have to be positive because it's opening up. We need to check for a pattern to see what the actual number is. It moves right 1, up 1, meaning a is a positive 1. The general equation, if you don't remember, is f of x equals a times x minus h squared plus k. It's also at the top of this page here that we're working on. We said a was a 1. You could either put a 1 there or don't put anything because it's understood to be 1. And it's x minus h, so I'm subtracting a positive 2, and then plus k, so I'm going to keep that sign, that negative sign with the 5, and put -5. The domain is going to be all real numbers. All parabolas will have a domain of all real numbers. You could also write it this way. And the range is restricted because of max or min. In this case, it's a min. Remember, you must write it down to up. So the lowest point has a y value of -5, and it goes up forever, -5 to infinity. We'll do this one together. Taking a look here, I see I have a vertex at 1, 3. So I have my h and k value. Now this time I'm going to have a negative a value. I know that because it's opening down. Looking at the pattern, I see I move right 1 and down 1. So a is going to be a -1 in this case. Writing the function, The A comes first, so I'm going to put a negative. You could write the 1 if you want. Again, it would be understood to be 1 if you don't write anything. X minus h, which in this case, oops, should have put a negative 1 there. So it's x minus a negative 1. Well, when you have two negatives, it becomes a positive. Scooch this over a little bit. So in my parentheses, I have x plus 1, and it's being squared because it's quadratic. On the outside would be my k value, which would be plus 3 because I moved up. Domain is all real numbers, or like I said, you could write it in interval notation. The range is restricted by this maximum here. Once again, down to up. It's going to go down forever, making this a negative infinity coming first. And then the highest point on the graph would have a y value of 3, so 3 with a bracket. Next, what I want you to do is you're going to try 6 and 7 on your own. So I want you to analyze the graph, write the function, and the domain and range. You also are going to be trying these word problems here. I understand it's going to be more difficult to attempt these. Do your best, try to be problem solvers, and when you're done trying examples 6 and 7 and the word problems, you're going to go to the next video, which is titled 2.1 Try Problems. Good luck.